Welcome to the 8th grade Math Homework Helper Series. Tonight's homework is Introduction to Functions, focusing on equations. We'll start by taking a look at question number 1. Number 1b asks to graph the following and determine if they are functions. So, for 1b we have y equals 2x squared minus 1. And although this looks similar to y equals mxb formula, the fact that we have the exponent forces us to look at this in a little different way. So the way that we want to deal with this is we want to set up a table where we plug in a value for x, which is then going to get squared, multiplied by 2, and have 1 subtracted from it. And that's going to tell us what y equals. And then from there we can set up a variety of points that we can then graph. So I randomly chose -3, -2, -1, 0, 1, 2, 3. It really doesn't matter what values you choose for x. So with -3 to start, I plug that into the formula. It works out to be 17, and it gives me a value of -3, 17 for my first set of coordinates. I then chose -2, plug that in. It works out to be a positive 7, and it gives me the coordinates -2, 7. For -1, works out to be a positive 1, so I get -1, 1. For 0, works out to be a -1, and it gives me 0, -1. For 1, it works out to be a positive 1 also, so I get the coordinates 1, 1. For 2, it works out to be 7, and it gives me the coordinates 2, 7. And for 3, works out to be 17, and gives me the coordinates 3, 17. Okay, now I need to plot these, at least some of these, on a graph and determine what kind of a line it creates, and then I can determine whether or not it's a function. Okay, so I started by plotting 0, 1, -1, which I put right here, and then I plotted -1, 1, and then I plotted 1, 1, which put them right alongside of each other, and then up here I plotted -2, 7, and then positive 2, 7 over on this side. Connected those, and I got this curved line. If there's two ways I can determine whether or not this is a function. I can look at this table and I can simply ask myself, okay, do I have any values of x that are doubled on this side, that are repeated, that don't have the same value y? And I don't. Every value of x I chose was different, and so therefore every value of y I chose is going to be connected to a different x value. That in and of itself tells me that this is a function. But if I wanted to focus on this side of it and look at the graph, I could also use the horizontal line, which I'll create one right here just to use to look at. If I take this horizontal line and move it through, you can see that at no point does my horizontal line, this orange line, touch the curved line in two places at once. It's only intersecting it at one place at any given time as I slide it across. So that also is an indication that this is in fact a function. And we have yes, because each x value has only one value for y. Now let's take a look at question number 2. We're going to look at A, C, and J. And we're trying to determine whether or not these are functions. And then we have to explain why or why it doesn't represent a function. Well, to review the definition of a function, it's a set of ordered pairs x, y such that for each value of x there's only one value for y. So, does the set of all positive numbers fit that definition? It doesn't, because we have to have ordered pairs. So no, because it's a list and it's not ordered pairs. What about y equals 8? Well, if I graph that out, that should create a horizontal line. And if I use the line test on a horizontal line, it passes the vertical line test, because I'm only touching it in one spot at any given time. So whenever you're graphing y, it creates a horizontal line. What about when you graph x? When you graph x, it creates a vertical line. Now, a vertical line's not going to pass the vertical line test, because it's going to sit right on top of it, and it'll be touching it in multiple places at the same time. So that won't work. Okay. Please use the problems that were done for you to help you to solve the additional problems that are in your homework tonight. Remember, the key to success in math is not only working hard, but working smart.